Cross limited control. Boiler total air control part 2. Automatic adjustment of the airflow with boiler load. This lecture is in continuation with the earlier lecture on topic optimum air fuel ratios for efficient boiler operation. The excess air within appropriate values leads to efficient and safe operation of the boiler. The green region of the graph is showing the safe and efficient operation of boiler. Airflow increase leads the fuel flow increase. Airflow increase should lead the fuel flow increase while increasing the firing rate of boiler. This ensures that excess air is always within appropriate values while boiler load is being increased. Airflow decrease lags the fuel flow decrease. Airflow decrease should lag the fuel flow decrease while decreasing the firing rate of boiler. This ensures that excess air is always within appropriate values while boiler load is being decreased. Airflow lead and lag. Airflow lead and lag is automatically provided with the help of cross-limiting control scheme as explained in the following slides. This diagram shows the basic cross-limiting control scheme. Request: it is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. The figure shows the principles of the cross-limited combustion control system. Individual controllers 7 and 8 are provided for the fuel and air systems respectively. Master demand signal is fed to each of these controllers as the set point so that the delivery of fuel and air to the furnace continually matches the load. Because fuel flow and air flow are each measured as part of a closed loop, the system compensates for any changes in either of these flows that may be caused by external factors. For this reason, it is sometimes referred to as fully metered system. The effect of the fuel-air ratio adjustment block number 4 is to modify the airflow signal in accordance with the required fuel/air relationship. The maximum and minimum selectors allow for differing response rates of the fuel and air supply systems. Consider what happens when the master demand signal suddenly requests an increase in firing. Assume that prior to that instant, the fuel and air controllers have been keeping their respective controlled variable in step with the demand, so that each of the fuel flow and modified airflow signals are equal to the demand signal. When the master demand signal suddenly increases, it now becomes larger than the fuel flow signal, and it is therefore ignored by the minimum selector block, which instead latches onto the modified airflow signal from item number 4. The fuel controller now assumes the role of fuel/air ratio controller, maintaining the boiler's fuel input at a value that is consistent with the air being delivered to the furnace. The airflow is meanwhile being increased to meet the new demand, since the maximum selector block number 6 has latched onto the rising master signal. On a decrease in load, the system operates in the reverse manner. The minimum selector block locks onto the collapsing master and quickly reduces the fuel flow, while the maximum selector block chooses the fuel flow signal as the demand for the airflow controller, item number 8, which therefore starts to operate as the fuel-air ratio controller, keeping the airflow in step with the fuel flow. Analysis of the system will show that it is much better able to deal with plant or control and instrumentation equipment failures. For example, if the fuel valve fails open, the air controller will maintain adequate combustion air to meet the quantity of the fuel being supplied to the combustion chamber. This may result in overfiring, but it cannot cause fuel-rich conditions to be created in the furnace. The system cannot compensate for all possible failures, but when coupled with self-checking diagnostics and proper fault detection techniques, it provides a high degree of safety. The figure shows the exact hardware blocks used in pneumatic or electronic hardware systems for combustion control. It has two drawbacks. The controller block number 8 shows a corrected airflow rather than the actual airflow. The signal selectors only work if their inputs are in the same units. In this case, percentage of boiler maximum continuous rating BMCR flow. Request. It is hoped that this lecture is useful to you. Please press like. Please subscribe.